ECT Tech Nuggets, Raspberry Pi, basic setup and config. So we're going to talk a little about Raspberry Pis today, using a bunch in different courses that we're working with. And, you know, we just kind of want to go over the basics. What is it? What isn't it? What can it do? What can it do? We'll go into some details about how to get the thing up and going, especially if it's headless. That means with no monitor, no keyboard, so we can access it remotely. A lot of times with these kind of devices, they're little appliances, so we don't want to do that, you know, a dedicated keyboard and mouse to them. Let's start off with Raspberry Pi. What is it? Raspberry Pi is basically a credit card-sized computer. It's a full-blown thing, right? It's a full-blown computer. It can run a desktop operating system that's complete with web browsers and, you know, Windows and run media and all that kind of good stuff. That means it's got a reasonably powerful CPU. It's got, depending on the model that you get, it can have anywhere from 1 to like 4 cores in it. So it can be pretty powerful, be pretty warm. It'll have heat that comes off it. There's actually heat sinks and fans that you can get for the bigger ones. The newest ones have about 8 gigs of RAM, which is just about enough to run a real GUI operating system reasonably well. The video card in them is kind of minimal, but generally speaking, you're not doing a whole lot with it. It's pretty minimal. Considering that the whole thing, all said and done, is about $50, that's cheap for a desktop computer. There are a bunch of accessories you got to add to it. For your $50, you don't get an SD card. That would be the hard drive. You'd have to buy one. So there are some things that it doesn't come with. So when they say it's a $35 computer or it's a $50 computer, yeah, well, that just gets you the board. That doesn't get you some of the other stuff. You need power supply. How do I get juice to it? Well, you got to buy one of those. It's another $10. So by the time you're done, the whole ecosystem, you probably got $100 tied up in it. There are a bunch of neat kits you can buy on the internet. Canna makes one that I bought through Amazon a few times. A Canna kit, which comes with a Pi and a power supply and a SD card and a couple other video cable that you'll need if you want to run it to a monitor. Doesn't come with a keyboard or a mouse. It's kind of assumed that you've got those around somewhere where you could get one if you want to run a desktop OS. Pretty nice stuff. Works pretty well. A lot of times I've had people ask me about what's the difference between a RasPi and an Arduino. One of my colleagues, Brandon Saunders, can definitely go into a lot more detail. His specialty is computer architecture and can tell you a lot more. I'm going to give a much more lay definition of that, which is basically the Raspberry Pi is going to be a full-fledged operating system. It's going to do multiple processes at the same time. Like I said, it's got 4 cores in it. So it's going to task switch and do a lot of that task switching, multi-threaded kind of work back and forth. Which is great when you want it to act like a desktop operating system. You know, I want to do 3 or 4 tabs in a browser, or I want to do a couple things at once. It's really great about that. The downside is it can swap out a task that's time sensitive. And sometimes we don't want that. Arduinos have made their name at doing one thing really well. If I use, I want to make this Arduino run a CNC machine, right, with a high-speed lathe on it, I don't want it to get distracted because somebody decided to run a web browser on it and all of a sudden it stops or it stutters or shakes. The drill bit on that thing spinning at 6,000 RPMs, we don't really want it to shudder a little bit in the middle of a cut. That'd be bad. And we don't know when it's going to happen because, the thread got preempted and yanked out so that we could load a graphic. Nah, Arduinos do really great at single task things. The way you get about getting into them is very, USB-ish, hard code-ish, and you turn it on and it does its one thing and it does it really, really well. Raspberry Pis are much more generalist in that category. Because it's a generalist, that gives us the desktop OS, and we can, as, lab people or as, people, electronics at home people, we're going to play with it. It's going to do what we want it to do, and it's going to be really great. If we go out into the real world and we want to build a product, we're probably going to not run it on a Raspberry Pi. But if you want to build a system that's going to manage the water, temperature, and humidity in your little greenhouse at home, Raspberry Pi is going to do a great job. And that, that kind of stuff is what it's for. It's for the hobbyist. It's for the lab person. It's for the student. That's kind of what we do with that. One of the limits that we run into with this kind of equipment, it's not designed to run forever. An SD card is a limited read-write cycles. And that means you run a desktop operating system on it, and it's going to read-write that thing pretty hard. You might get a year running a desktop operating system out of it, and then it's going to die. That's okay. That's normal. You make sure you have backups of your data and backups of the SD card, and you flash a new one and move on. I'm going to talk a little about how to do that card flashing kind of stuff a little later. Actually, my next slide's about it. We're going to talk a little about what that means and how you get those images and how you put them on the card. But you should be aware that the hardware is not a forever kind of thing. It's not designed for that. If you need an appliance that's going to last forever, that's where you go get it. My parents have complained about how washing machines only last 10 years now. Yeah, we're getting down to now where your cell phone lasts 18 months and it's trash. Why? Because new stuff comes along. It's unfortunate for our landfills, but it is the reality of the hardware that we live with and deal with every day. All right, so how do I get this thing up and running, right? I've got the card, I've got my Raspberry Pi, I've got my SD card. What do I do? There are pre-made images of the software ready to go. So it gives you everything you need to start with and gets it up and running and rolling. And that's great. And there's a link here where you can download a blank, pure, whatever term you want to use for that, of the Raspberry Pi operating system. There's a couple options. There's a desktop version. There's actually 2 or 3 different versions of the desktop version. Some come with more pre-installed apps. Some are more just a blank, desktop operating system. There's a light version, which is basically just the server. And that means no desktop GUI. You boot it and it's just going to run that. I tend to use the server version when I just need to SSH into it. I just need terminal access to it. It keeps the read-write cycles down on the card. So if I'm going to deploy out, for some reason I want to deploy out these things, the server version will last much longer on your SD card and won't have as many read-write cycles. And that's generally why we do that kind of thing. All right, so I've downloaded the image file and I've got it on my desktop, and how do I get it onto the SD card? And oftentimes you'll have an SD card reader. My Cana kit that I'm going to talk about here in a little bit, I've got some shots of me using this piece of equipment. It's got this little SD card USB reader, and you put the SD card in it. You might have used one if you have a fancy camera where you pull the memory card out of the camera and you stick it in the card reader, and then you stick that in your computer. That's what this same thing is. These cards are literally the same ones you'd use in a fancy digital SLR camera. Same kind of thing. It's a little SD card, stands for secure digital. It's what SD stands for. But we use them a lot in a lot of other things. Yeah, you're going to burn it using a piece of software called Etcher or Balensa Etcher. There's a number of different software packages to do this. I'm going to demo the Balensa Etcher one. It's easy. It's recommended by the Raspbian people. Works in Windows. I think there's Mac and Linux versions of it too. It's a really lean and mean one. I've used one called Rufus, which I use for a bunch of other things, for booting off of jump drives and booting off SD cards and stuff like that. It's got a lot more features, but for just burn the image so I can boot my Raspberry Pi, the Balensa Etcher does a great job. One of the first things you'll notice when you put the card in the card reader and stick it in a USB slot, in Windows anyway, your operating system will come up and immediately say, ooh, I want to format this thing. No. The format that is on the SD card is not readable by Windows. And so it looks at it and says, oh, well, we should just wipe this thing and start over. No, don't do that. If it ever prompts you with that, just hit cancel and move on. It's fine. It'll do it every time you put the SD card reader into a USB slot and try to pull it up in Windows. It'll do it every single time. And you just hit cancel on it. If you format it, it'll blow away the Linux install or the Raspbian install that's on it, and then you'll have to go back and reimage it. It's a bummer. Yeah, just hit cancel and move on. It's normal. I've got a video of some of this, so we'll move through here. This is Balensa Etcher. You can see we're going to flash from a file. We're going to select the file. We're going to pick the select target will light up, and you'll pick the SD card reader, and then you'll press flash. It took me 13 minutes on my machine to flash the SD card. So you will need to wait quite a while. It'll flash the drive, and then it'll go back and verify that it wrote everything that you wanted it to write. It's kind of a pain that way, but hey, that's software sometimes. By default, once we get it imaged on there, we're going to want to leave the SD card in our desktop operating system, right? We're going to leave it in Windows so that we can work with it. The bigger problem is that if you were to boot it right now and you had a keyboard and a mouse, it would work fine. It'd come up, you'd be able to log in and do everything, it'd be great. But we're planning on running this thing headless, right? No monitor, no keyboard, no mouse. How do I get to it? It's a classic chicken and egg problem. How do I get it on the network to give it an IP address when it doesn't know anything about my network? We're going to solve this problem with 2 things. So we're going to leave it in our Windows machine, and we're going to go create one file that will enable SSH, right? That's our terminal access. And when the machine boots and it sees the existence of this file, it will enable the SSH server and we'll be allowed to SSH into it. The second one is a file that's going to define our wireless network wherever you are. And it's going to work for WPA2. And if you're a wireless nerd, that'll mean something. And if not, it won't mean anything. And that's fine. And it'll enable the Wi-Fi. It'll be very similar to the information. Actually, it's identical to the information. If your friend comes over to your house, wants to use your Wi-Fi, you've got to help them pick it off the list. It's this network, and then you give them the password. And that's exactly what we're going to do in this text file that we're going to talk about here next. All right, so I've got a screenshot here of an Explorer window, and down at the bottom, I've highlighted 2 files. And I plugged that in, and you'll notice up at the top, it says gboot. The boot folder is a Windows readable folder. And when you plug your jump drive in, it'll actually show you 2 drive letters. And one of them creates that error. And the other one is the boot, where you can actually look at and add files and things like that. So you'll be able to go in and you can right click and say create file, and you'll create an SSH with no extension. Windows likes to hide extensions. So you may need to go and have it show extensions, because otherwise it'll show it as a text file, not as an extensionless file, which is very frustrating, believe me. Windows is trying to quote unquote help. Just the existence of that file is all that needs to be in the root directory of the boot partition there. The other one is a WPA_supplicant.conf file. And I'm going to talk a little more about that in the next slide. Again, it needs to not have a text extension. And more importantly, it needs to be in the Unix end-of-line file format. I've used the screenshot that you're looking here as a product called Notepad++. You can see in the bottom line of that application, it says Unix, and then parentheses, it says LF, line feed. In Windows files, it'll say Windows, and it'll say control line feed. You can go read about the holy war that goes on between text file formats, which I find to be moderately idiotic, but hey, it's a thing, I'm sure. In Notepad++, which is one of the reasons we use it, you can right-click on where it says Unix and select Windows, Linux, whatever you want. There'll be 3 options there, and you'll want to pick the Unix one. And then when you save that file, it will save it with the correct end of line, and that's good. Also in this file, you'll see it says SSID, name of your wireless network. Now you need to leave the quotes, but then take everything out between the quotes and put in your network name. So whatever would show up on your phone or on your laptop, that's your SSID. The PSK stands for a pre-shared key. Again, the quotes stay, but everything else comes out, and you replace it with whatever your Wi-Fi password would be. So whatever your friend comes over and says, what's your Wi-Fi password? You put that in there, and you save it with the Linux file format. And when you boot the disk, the SD card, it should connect to your Wi-Fi network and then enable the SSH password. At that point, you only have one other chicken and egg problem, right? Assuming that all went right, it'll come up on the network and get an IP address, hopefully from DHCP in your local network. But how do you know what it is? There's a couple ways to find out. We're going to do it in the practical demonstration. One way is use Nmap and Nmap your network, and that'll go out and look all over the network, and hopefully you'll find a client on there that's named Raspberry Pi, and you'll say, oh, it's that one. Or if you have access to it, your router probably which is what's running likely in your home network, is running your DHCP server. You can look at the leases folder, and there's probably a listing of all the IP addresses it's handed out, and you can look on the router and it might show it there. That would be the other way to do it. All right, so we will go on to the practical demonstration where I will go through this process, and I've got some video of me playing with or Brandon actually, playing with the SD card reader, and I'll do some of that kind of stuff so you can see it. Okay, so Brandon is showing the Cana kit here, which is a kit we got from Amazon. He's got the USB card reader. That is an SD card. Secure digital, lots of writes, lots of reads. Does wear out eventually. 32 gigs is plenty big for what we want to do. And it's going to go in the Raspberry Pi, which we'll show here at the end as he puts the card in the Raspberry Pi. But first we're going to put it in the card reader, which is an odd little device that'll allow us to have it show up like a USB stick. And you can see there kind of close up, and it's going to fit on the bottom there. And he's going to grab it, and we'll be able to see the red side, the top of the card as he puts it in there. And you want to push it in kind of firmly. There's no spring loaded, there's no latch. You just kind of shove it in there real firm, and you pry it out with your thumbnail or something like that, and it pops right out of there. The Raspberry Pi is going to work the same way. There's a slot on the bottom of it where you're just going to push it in there, and there's no spring loaded or anything like that. And you put that, as he's showing you there, into the USB on your computer, and it'll show up like a USB stick would for any other kind of data device. You may have used one of these if you've ever done a camera or something like that. So Brandon's going to show how you put it in the bottom of the Raspberry Pi. It works basically the same way. You'll be able to see the red side as he shoves it in there with his fingernail, and it just kind of pushes down in there. Doesn't go a whole lot farther than that. Looks great. You can pry it out with your thumbnail if you need to. Not a big deal. All right, so he's going to plug in the micro HDMI connection so that he can boot it and see. You can show what it looks like. Right now, he's got the stock Noobs load on it, which is what comes with the Canon kit. There's two ports. There's HDMI 0 and HDMI 1. If you plug it in, you'd want to plug in a keyboard, a monitor, a mouse, and there's USB on the one side of it that you may have seen as it went by. This is USB-C power. Your Canon kit actually comes with a really nice power switch, so it's easy to turn off and on. And then you'll see here it's posting. It does a color test at the beginning. Post is power on self-test. So it's posting here, and it'll come up to a GUI that'll talk about installing. Noobs starts you at the beginning of installing the GUI OS and things like that. We tend to skip over that because we're going to reflash the card with stock Raspbian and go from there, which will come with the desktop. But of course, then we're back into that chicken and egg kind of problem. Flashing in a Valencia Etcher. So as we go along, you can see we've got Valencia Etcher, and we open it up and select the image file and hit open, and we select the target, which will be our mass storage device, right? You can see it's 32 gigs, just like the card, and we hit go, and then we hit flash. This takes a really, really long time, like 13, 14, 15 minutes. So I'm going to do some time compression, and we'll come back at the end of this so that you don't have to sit through it all. All right, so here you can see it's finished up and is, completed. It's going to validate, and once it's done validating, so it writes to the card, make sure it gets all written out, then it turns around and validates what it's written to make sure that everything went okay when it did that kind of stuff. So that way you get a solid read and write, and it's doing what it needs to do, and you're not going to wind up with anything wacky on your card. From there, you're going to want to leave it in the computer. We're going to close Valencia Etcher, and we're going to need to add a couple of files, like I talked about, on the boot partition. So it should show up if you get that cancel message or get that format message. Make sure you hit cancel, and we'll go through some of that too here in just a second, and I'll show how some of that works. All right, so Etcher has finished, leaving me with the SD card, plugged into the computer still, and I get the error message that we talked about. So we'll hit cancel on that, and we'll go up to this PC or my PC, or in Windows it has a couple of different names, and you'll see all the different drive letters that I've got. We're looking through the list, looking for one here called boot. And every time you plug it in, it's going to put two drive letters in. One's going to be this USB drive, which is where the I want to format it message comes from, because Windows sees it and says, I can't read this. I should format it. Thank you for being so helpful. The other one is this boot drive. Boot is the name of the volume label that goes with it, so we'll call it the boot drive. It'll have a number of different drive letters. Whatever it shows up on your system is fine. When we double click on it, you'll get a listing of files, which is what we want. And we'll be able to, see all the files. Now, Windows very helpfully will hide the extension of files that it thinks it knows about. And the extension on this file is .dat or DTB. But you'll notice a bunch of the files don't have anything. However, when we look at issue up here, we'll notice that issue is a text file. How does it know that? Well, it knows that because it's not showing the extension for the file of .txt. It's hiding it. So we need to get it to show us all of that. So I'm going to stretch the window a little bit and go up to the view, and you can see there's some checkboxes over here. And if I make it smaller again, those checkboxes go away when I look at view. So we may need to stretch it kind of wide and go to our view, and we'll need to say file name extensions. And ta-da, look at that. All the file name extensions show up. The other one that I really like is showing me hidden items, because there are hidden folders that it will hide from us. So oftentimes that is quite useful to do. And now I can see all of that. And if I go change the extension, Windows will scream and holler and yell and say, hey, you're going to change the association with this file. So how does it know it's a Word document? It has a docx on the end of the file name, and it knows that. And as long as you keep the docx, it'll know it's a Word document, and it'll always open it with Word if you double click on it. In our case, we need to create two files. So I'm going to right click and I'm going to go to, new, which is going to go right off the edge of my screen. So we'll put it over here and we'll go to new and we'll go to new and we'll go down to text document because that's the easiest one. Now, notice it's creating a text document, which we really don't want. We need to create an SSH with no extensions. So we may need to go and rename the file. And you notice it's highlighting it, but now that I can see the extension, it'll actually let me take it off. And it'll complain and say, hey, I might not be able to get to this. It's a text file. It's actually a 0-byte nothing file at the moment. And we're going to say yes, and it's going to just make a 0-byte file. When the Pi boots, it's going to see that file and say, oh, I should have SSH enabled. And it'll enable the SSH server on the network, which is what we want. It'll also delete the file, which is good because we don't want it there later. We may want to turn off SSH, and we can put a different file in there that'll let us remove it. This will work well, but we don't have any way to get it on the Wi-Fi, which is what we need. If you've got a cable, you can plug it in. It'll automatically get DHCP IPs and come up, and you can skip the whole create a supplicant file, blah, 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 and move on. If you don't have a cabled Ethernet connection, you'll have to set up the supplicant file, which is kind of a pain. But again, it's the creation of another file here. So we're going to say file new. And I'll do it a little higher so you can see it. And we'll go down to text document, and it's called a WPA underscore supplicant, supplicant.conf. And again, Windows is going to want to put an extension on it, and we're going to say no thanks, and it's going to complain. It's fine, let it complain. I've got Notepad++ installed. It's the recommended package that we're telling you that you need to use. It's free, Mac, Windows, Linux, all that good kind of stuff. So my .conf extension is already set up with Notepad++. So when I double click on it, it will open Notepad++. You'll notice it's a 0-byte file. There's nothing in it. We're going to put some stuff in it. And again, when the Pi boots, it's going to read that and it'll allow it to log on to the wireless. So I've already got staged the text that needs to go into it. So I'm going to copy and paste it. And it's available on in the slides in the lab. It's also available, I think, on the website for the lab. And it looks like that. And we changed it to say US from the stock one that you might see on the RasPi site. And we also will need you to go in and add whatever the network name is of the network at your house or wherever you're using this, along with the password. This would be the same information you'd use if you needed to get your phone on the Wi-Fi at that location. You'd put that username and password in and you'd save it. There's one caveat. This is a Windows editor, and Windows has some funky line endings that we talked about. But in Notepad++, which is why we use it instead of regular Notepad that comes with Windows, we can set the kind of line endings we want. We come down here to Windows, and we right-click on it, and we say Unix line endings, and it will save Unix line endings. And all I have to do is hit save, right? We go up to the little, that's actually a floppy disk for those of us that are, don't know that. And we hit it, and it saves the file. And that way it will save it with the right line endings, and it will save it with all the different things in it that need to be there. All right, from this point, I'm going to close it all. You can go into boot and right click and say eject. And this will flush all of the files that might be open. The operating system might be holding it open, and we say eject, and Windows will remove it all, right? It removed both drive letters, and I can pull it out of the machine, and it'll remove the unreadable partition. And at this point in my hand, I've got my USB reader with my card. I can put it in the Pi and boot it, and it should jump on to the Wi-Fi, and I should be able to SSH into it. And I will have some demos of Nmap. How do you find this thing when it's on the network and I don't know its IP address? So we're going to use Nmap. That doesn't work. We've got some other tools that we can hunt and try. We've had really good success with Nmap. Sometimes there's some other ways to do that. So I'll come back here in just a second, and once I get my Pi up and running, and I will demo Nmap. All right, so this is a Windows command prompt. I'm using Windows Terminal, but it's essentially the same as a Windows command prompt. I've downloaded and installed Nmap from the Nmap website, which was detailed earlier in a different Tech Nugget. And I've got my Pi on. It's booted. It's little red lights on. If you take the top off the can of case, you can see there's a little red power light and there's a green activity light, which means it's reading and writing off the hard drive. And you can see that kind of greatness as it goes, or you can put the lid on it and ignore it, which the rest of us do. Nmap is a great tool. It can be used to do a lot of different things, from ping sweeps to intensive mapping and thumbprinting of what's going on. It's definitely one of those tools that if you turn it loose on somebody else's network, you're going to get some hard looks. Somebody's going to come asking questions about why you're poking people. So please be careful with it. It's important to remember that. What I've got set up here is Nmap with some specific switches for my network. So your mileage may vary a little bit in the use of this. So I've got a -P option, which means we're going to do a port scan, and I'm looking for port 22, which is where our SSH server lives. It lives on port 22. And I've also given it the subnet that my Pi lives in. These are all required things that you got to give it. If you don't know what your subnet is at home, you can probably look at your local machine and figure it out. It's probably 192.168.1.0/24, but it might not be. It might be something else. It depends on your local equipment and what it's configured for and that kind of thing. So that'll be the kind of thing you need to know ahead of time. Nmap output can be a little archaic. So I'll run the command here and you can see that it starts running. It can be a little archaic as it runs, and it can take a little bit of time to chew through all of them before it comes back. And you can see here it's gone off and it's done a little looking, and I'm scrolling up here so that we can see a little bit of it, and it's found a number of hosts. And the one we're looking for, is this one. And unfortunately, it puts the Raspberry Pi at the end, showing its MAC address and the fact that it's open, and it gives its IP address, which is really what we want. I'm going to right click and I'm going to mark and copy that so that I can use it to do an SSH. And we'll do an SSH and a Pi because that's the username, and we'll give it its IP address, which is 10.101.3.150. And the first time I log into it, it's going to say, ooh, I don't know this other end. Is this the thumbprint you're expecting? And you could go look up that thumbprint, or you can do what most of the rest of us do and say, yeah, sure. If you happen to SSH to the same IP twice, like you reformat your card and do it again, you'll probably get an error that says, hey, I've already got a thumbprint and this one doesn't match. So you want to be careful of that. I'm going to say yes, and it's going to ask me the password, which in this case is Raspberry, I think. R-A-S-P, B-E-R-R-Y. There we go. Raspberry. There's a P in there. That lets me in. First thing you should do is change your password, P-A-S-S-W-D, right? And it's going to ask for the current password, R-A-S-P-B-E-R-R-Y, and I'm going to change it to the standard thing that we use in class. And there my password's now changed. So when I log in the next time, I'll be able to have my updated password and that kind of thing. This is dropping into a command prompt. You can do all sorts of great things that we'll do at the command prompt. And this is one of the primary ways. SSHing will be the primary way, unless you've got a monitor or keyboard, that we'll go about getting at Raspberry Pis, especially headless ones. Well, I hope you've enjoyed this Tech Nugget, and we'll see you for the next one.